Hello everybody and welcome. Thanks for joining us today for Model Cities with the tech behind Independence Day Resurgence. My name is Dominik Tarolli and I'm responsible for the global 3D and geodesign business sector at Esri in Redlands. With me today is Matthias Buehler, founder and owner of vrbn, and he was also the lead environment developer at Scanline for Independence Day Resurgence. Matt, glad to have you on the webinar and welcome. But before we start, let me also say thank you to the Visual Effects Society. Nancy and the whole team did a great job to make this webinar happen. Then also Scott, Bobby, Martin, and the whole staff at Scanline for the collaboration. And last but not least, Dougal, Justin, and the whole team at 20th Century Fox. Thank you very much. We couldn't do it without your support. Now, what is on today's agenda? First, we like to bring everybody on the same page with CityEngine. Then we jump right into the work that Matt did for Independence Day Resurgence. And at the end, we should have some time for feedback and Q&A. Hope that works for you, and before we start, we just have 3 housekeeping items to cover. First, if you have a question, please feel free to use the question window, type in your question, and then click send. Second, for your convenience, we set up a box folder with all the content and links from today's webinar. You can access this box folder at bit.ly/VES webinar_1607. This URL is case sensitive, so please write it quickly down or make a picture screenshot right now. Okay? And we will repeat that URL one more time at the end of the webinar. So if you want to meet CityEngine Mastermind, Pascal Müller, and myself there for a personal meeting, please use the link bit.ly/sigraph_2060. But now let's get started with CityEngine. So CityEngine is a standalone software for Windows, Mac, and Linux that does one thing very good: computer-assisted creation of urban environments, which basically means procedural modeling of cities and buildings. And why is this so important or valuable? Cities as digital film sets are beautiful and even become essential characters of movie blockbusters like Cars 2, Total Recall, Big Hero 6, Superman, Man of Steel, Zootopia, and so on. But the challenge is that even small cities comprise several thousand buildings, facades, streets, street furniture, lights, etc., and a lot of details like roofs, different windows, etc., and easily can become a very time-consuming and tedious production task. So the solution here really is to use a procedural modeling tool like CityEngine to create beautiful and massive digital film sets. And CityEngine has enabled artists now almost for a decade to create digital sets far more quickly, at larger scales, and with much greater detail than ever before. Therefore, let us now dive in right into CityEngine work for Independence Day Resurgence. I hand it now over to Matt, and as already mentioned, Matt is the founder and owner of vrbn, but he was working as the lead environment developer at Scanline for Independence Day Resurgence. Matt, I make you now a presenter, and I hand it over to you. Matt, the floor is yours.
Thank you so much, Dominik. Can you see my screen and hear my voice?
Perfectly, yes.
Perfect. Okay, yeah, thank you, Dominik. So let's get started with my part. Welcome to the presentation called Model Cities with the Tech Behind. Ta-da, Independence Day, who would have guessed? I hope everybody in the webinar has already seen it. Otherwise, spoiler alert. Welcome to a world of destruction. Or maybe better, to a world where I have helped creating beautiful city models and other people had fun destroying them. This technical shot breakdown is a part of the Singapore sequence that shows how strong the gravity of the alien mothership really is. No wonder when that thing, that huge spaceship, has a diameter of about 3,000 miles. As we see, literally everything gets ripped off the ground. We can see the skyline and the bridge that were hand modeled in a manner that destruction simulations can be run on top to rip them apart, create smoke and debris. Then further in the back, there are about 20 city chunks where CityEngine was used to fill in the complete layouts with streets, trees, and thousands of individual buildings. Here, a bit more close up, we can see clearly the incredible forces and the sea of flames that seems to devour everything. I guess the images speak for themselves. I have to say I love it. Okay, quick intro. First, the outline. We have 5 topics, then I hand the presentation again off to Dominik for his summary. We'll be talking about my tasks, the technical challenges, and the solution we have developed. So, who am I? My name is Matt Buehler, as Dominik already mentioned. Now, my background is in architecture. I received my master's degree in 2007. Just recently I founded my own company called vrbn, but a bit more about this later. I was invited to hold this presentation and talk about how CityEngine was used on this movie, as I was specifically hired as environment developer lead at Scanline VFX to implement an efficient workflow for the creation of procedural cities. I have also released a Gnomon workshop training video about CityEngine, of course, which may be of interest for some of the people in this audience, as it is VFX related also. Further back, I was a CityEngine consultant and I've worked in the CityEngine development team in Zurich. Okay, what's the topic today? Today I'm specifically talking about the use of the software called CityEngine in the production of the movie Independence Day Resurgence at Scanline VFX in Vancouver. And by the way, never go to Vancouver in winter, it's very, very rainy. So, what is CityEngine? CityEngine is a so-called procedural modeling application dedicated to the creation of three-dimensional cities. The basic principle can be explained relatively easily. With one shape and a so-called rule, a model is generated. And if we repeat this process lots of times, we create a city, basically. So examples of a shape can, for example, be a building footprint, a parcel, or a street shape. The rule then takes this shape as an input geometry and processes it into the resulting model. Rules are already available for downloading for free, or if you need quite specific rules, CityEngine service providers such as, for example, vrbn can of course help out. What were the tasks I was given? Of course, not everything was defined from the very beginning, but some of the key objectives were outlined as: there will be multiple environments in multiple cities. Which cities or how many shots, respectively environments, have to be built could not be defined from the beginning. Then the size and layout need to be flexible. This means also scalable to very large areas. The buildings have to look as realistic as possible. Then the workflow has to be integrated in the pipeline in a collaborative manner. And the whole solution needs to be implemented in a relatively short time frame, obviously. Now, this is a daunting task if you consider the complexity and the fact that you need to have first a working system to prove that it will work before you can actually start creating the production-ready environments. So what were the technical challenges? First of all, as just mentioned, big environments. Example in this shot breakdown. The city design on the left looks like the Taj Mahal. I'm not going to talk about this as it was provided by another studio. But the whole part on the right here, that was a small part actually of a large-scale procedural environment around the hospital in Washington that was built in CityEngine and gives a pretty clear first impression of the scale of just the toes of the mothership, visible here in the background. A bit closer again, we have some buildings in the foreground that were manually modeled, ready for destruction effects, combined with a huge simulated pile of city rubble that is pushed in by the landing spaceship. One thing, and again here is the CityEngine environment just in the background or in the midground actually. One thing that is easy to miss, but actually a very impressive fact is that the size of this midground environment behind the foreground buildings here is around 3 miles of distance up to the next toe back here. So that is a full, complete 3D environment with streets, trees, and buildings. Another angle here again from the hospital platform. Sadly, the city is hidden, but the breakdown shows very clearly the structure of the shot. The environment on the other side of the hospital was of course also built and is visible in the movie, showing Washington over a distance of about 4 miles in the other direction. Now, with big environments come vast amounts of geometry. The approximate accumulated area is around 30 square miles that we have produced. While the biggest connected environment around the hospital, as we have just seen, is about 15 square miles. All combined, in all of the shots, we have created around 150,000 unique buildings. Second point is a vast amount of materials which were created procedurally. So as basically every building has its own material and color mix, controlling the materials and having them rendered correctly was technically quite tricky. Further, of course, the believability of the environment itself. So to start, we've had a look at different types of real-world data, such as GIS data that is available for free on the web, like OpenStreetMap, or just simple satellite pictures as a reference to decide on a direction to continue. Reason for this is that density studies and studies of the local so-called geotypical architectural styles is crucial for the look. And as often the story in a movie just plays in the future or in the past, you cannot really use a one-to-one real-world city model. This is just sometimes tricky. But though, meanwhile, in the visual effects industry, it's quite common actually that LOD1 and LOD2 3D GIS datasets are used for projection painting to get realistic parallax effects. Then our physical world has an endless amount of details. So reducing the amount of details to the necessary minimum for maximum efficiency is a crucial part. Then, this type of work also has a very clear component of actual urban planning. So, for example, when defining realistic value ranges for attributes such as building heights, vegetation density, or street widths, some of these values just need to be spot on to make a city look believable. So it becomes quite obvious that the goal was the procedural control over the whole urban fabric and not only the individual buildings. Just as a side note, CityEngine 2016 has just released a very cool new feature called Get Map Data. It basically allows you to select a geographic region, and it will automatically crop and download the according satellite picture and optionally also get some OpenStreetMap data. If you have a subscription, the user can also get access to some elevation data, so basically the terrain. I think this is a really cool starting point for projects in visual effects and in other industries, as it allows you to generate a first mock-up of a city part within literally a couple of minutes. The second big challenge was the pipeline integration. Of course, it was the goal to find a solution that enabled all of the involved departments to collaborate as close to the existing pipeline as possible. Next is porting all the generated data from CityEngine and storing and loading it efficiently for actual rendering. Another aspect was managing managing the workflows and the whole milestones for features and implementing literally only what is needed at a specific point in time. Also, leveraging existing assets such as trees, cars, AC units, and so on was tricky. Including, obviously, that always has to be in the list is naming conventions, and so on and so on. Now, as you see, there were lots of things to develop and to keep track of. Iteration cycles. There were 4 main roles I was combining in my person for some time that had all different iteration cycles, and I think this is quite important here. Those were, number 1, workflow implementation proposals and the execution in collaboration with the pipeline developers. Second, the rule development. Third, look development. And 4, the dailies. Now, the first one is relatively clear. The more complex a feature was, the longer it took to implement. That's quite logic. This cycle was usually from between 2 days and a week, or 2 weeks, depending on the importance and complexity. Then the second one, writing the actual CGA rules specifically for the show, usually took a couple of days, but it always also involved managing other artists for the creation of specific assets and specific textures. Then look development, which is also known as shading, is the discipline of making things look right. That is both for texturing objects and material settings, and also obviously render settings. This was a rather continuous process where we gradually added more features to the overall look of the buildings, including fine-tuning certain values such as reflectivity or transparency values. And the only one of the 4 points that is actually directly a creative process was using the system to create the urban layouts. And for those that don't know the term dailies, the term actually refers to the daily meetings to discuss the progress and the next steps. It was not always possible or needed to have dailies, of course, but we've had it many times where our VFX supervisor, Mohsen Moussavi, requested specific new environments, and he got the initial layout rendered literally the next day. The typical design iteration until a layout was finalized was on average about 3 to 5 iterations, which is pretty good. Which brings us to the famous turntable. Turntables are quite common in VFX for quality control of all sorts of assets. Now, the beauty of a truly procedural or rule-based modeling workflow is you can simply decouple the rule creation process from actually designing the final layouts. So we decided to create a default sandbox scene on which we develop the CGI rules with all the features necessary, with the guarantee that it then will work on any context or any environment. The aspects of this process were, for example, as mentioned before, in the lookdef field, or in the lookdef field, basically to, for example, fit shader values or find fitting shader values, reflectivity, and so on. Otherwise, also, for example, color palettes, finding missing asset categories that need to be implemented, desired architectural styles, facade types, distribution densities, and so on and so on. And of course, we produced many iterations of this turntable, each one adding more realism, detail, and artistic freedom to the rule set. I would say this was the key component to all of the CityEngine design and implementation work we did. Next to the technicalities we have discussed so far and the features of the tools we have developed, we also needed a clear artistic process that is easily understandable, shows the possibilities, and defines artistic milestones for the development of production-ready environments. We have developed the following process together with other artists and VFX supervisors so that the whole workflow could then also be taught to other artists. Over the next couple of slides, we will discuss the iterative refinement of an example environment. We start with an initial proposed city layout represented as simple boxes, based on, for example, an artificial satellite picture from the layout department. So this is obviously just a very small example, but this could be as big as you would like, basically. This type of representation has earned the straightforward name density box. As in urban planning, this lets the supervisor now decide where quote-unquote mass needs to be distributed. In this case, we have decided that we were far off and half of the city needs to be a lot denser. So before, after, before, after. It can also be that we have to go with a lot less density. Or if we are happy with the overall density, we can switch to a geometric representation called building shell, which shows a clearer building definition to define a little bit, or to have a little bit more refined and precise look. It can also, of course, be that we decide to go to the version we had just before with the higher density, but now in this type of representation. The next step is the actual heart of the system, the high resolution representation, literally one click away from the last representation. This now represents the final quality model that is ready to be rendered. And of course, we can now go back to the beginning and say, we would like to refine the environment at the level of individual parcels or buildings. So in this case, we delete one building, we add a new density box, we fine-tune the density, switch back to the building shell, and again switch to the high resolution version. Now, in case we don't like the building material, it can be overridden. So in this case, we see this is the standard, the default, and we switch to, for example, concrete material. And if necessary, this can obviously also be done again for multiple buildings. As you can see, these steps are quite straightforward, but are necessary to lock down certain things while fine-tuning other aspects of the environment design. A separate note on the building shell representation we have just seen. This representation is actually co-exported with all the high-res exports automatically. This is one example of the super simplified representation that strips out basically all the details that we don't need for this representation. And this representation actually has two main uses. First of all, it can be used as a very lightweight city representation so that it can be easily animated in space. But also, this simplified representation can be used for all sorts of collisions, or, for example, to emit large-scale fire directly from, basically from the geometry of the city. Beautiful. And also in this shot, another example of how city parts can be animated in space. Yeah, there we are again. At this point, I would like to thank the Visual Effects Society and Esri to organize this webinar and have me invited to speak. And of course also Fox and Scanline for both the prestigious opportunity and the provided imagery. Special thanks from my side go to Bobby and Mason, who initially contacted me. And of course also to Danny and Stefan and the rest of the Scanline team. This is much appreciated. A few last details. First, CityEngine was used in 35 shots that Scanline has provided to the movie. A lot more than were initially planned, which I believe is again a proof how powerful CityEngine really is. Secondly, the jaw drop count was pretty high from the beginning on, when people started to get to know the tool and realizing the potential. And the best of it all is now obviously that the rules are now available to other artists at Scanline to produce hopefully many more fantastic movies with them. We'll see. As quickly mentioned in the very beginning, I have literally just started my own business called vrbn. I will provide all sorts of city services in the field of visual effects, GIS, architecture, urban planning, and so on. So if you have any questions regarding this presentation or other inquiries, don't hesitate to contact me via either the email address, homepage, my company handle, or my personal Twitter handle. And last but not least, to round this talk off, just a few more still images of what we have just talked about. First of all, huge cities, burning cities, flying cities, and as Jeff Goldblum's character in the movie says, what goes up must come down. Thanks a lot, and back to you, Dominik.
Thank you so much, Matthias. Great presentation, and it was truly amazing. Thank you so much. And before we start with the Q&A, actually just 3 things. First of all, we just released a new version of CityEngine 2016. And this version is a total game changer. And one of the exciting features you mentioned already, Matt, but the other one is the brand new Alembic exporter. The exporter enables CityEngine users to handle massive 3D city models out of the box without the need for advanced production pipelines or tedious workflows. So the Alembic cache files written by CityEngine can be read by popular 3D tools such as Houdini, Katana, Maya, or renderers such as V-Ray or Pixar's RenderMan. Second, I already mentioned that we set up a box folder with all the content and links from today's webinar. You can access that folder at bit.ly/VES webinar_1607. And thirdly, if you're going to SIGGRAPH next week in Anaheim and you want to meet with us, please use the link bit.ly/SIGGRAPH_2016. But if you prefer to ask your question right now, that will work as well. So if you have a question, please use the question window, type in your question right now, and then click send. That's the thing you have to do. And we have already a lot of questions. I would say we are taking the first 3, and then Matthias, I think, and myself, we will get back to you after the webinar by ourselves. So let's get started. The first one is from our friend Devin. Was the turntable produced in CityEngine? Can you say something about that?
Yes, I can, of course. So
basically, and if no, there's the same question. If no, what was the procedure in moving from CityEngine to the software? Sorry.
Yeah, no problem. So yes, the turntable scene was produced in CityEngine, and then basically the standard procedure was to export, or to use our exporter that we have developed. Read in 3D Studio Max, and then the actual turntable, the animation of, or the rotation plus the rendering, so the video actually, which I have shown you, that was then rendered inside Max with the Scanline standard renderer, which is V-Ray. I hope this answers the question.
Okay. Then another one is coming, and I can tell you there are tons of questions here, so we're just going after the one from Georgia, and she's asking, can you chat a moment about pipeline for CityEngine and Cinema 4D? And since I know you were also working in the past with Cinema 4D, maybe you wanna mention 2-3 things.
Yes, that is certainly possible. Now I'm not completely up to date if Cinema 4D now also supports Alembic. I'm a little bit out of the loop with Cinema 4D myself, but the workflow would have to be adapted, of course, a little bit with potentially maybe other scripts and other file formats or so. But it would definitely be possible, because in the end it's it boils down to porting, first of all, the geometries, the instances, and the materials. And if you have these three components, then or solved a technical workflow to port all of these three types of data, then you're good to go.
Okay. Then another one from David. And what kind of modeling and workflow process did you use for terrain modeling, and how did you adjust the terrain? And that's basically a very good question, just in respect to CityEngine 2016. Do you want to say something about that, Matt?
Yeah. So in all, what should I say? In all honesty, to keep things relatively simple, we kept everything flat. But in case we would have had some pretty specific elevations, then we would have to had adapted, for example, or a couple of the CityEngine rules to that. Now, I mentioned a couple of, or at one of the slides in the middle about this, the agile approach or the extreme programming approach. This was exactly one of the things, or this is a very good example of one of the features that was discussed, but we actually never used it, so it was not implemented right away. Some of the things, so basically to adapt the cities to the terrain, is certainly possible, but for the stuff I needed it, or for the CityEngine stuff, it was not really relevant.
Okay. And one question, one last one. There are so many, Matthew, we have to answer them after the webinar, but one last question I think which could be from great interest is how much programming or scripting language is required to use CityEngine? Can you elaborate a little bit on the different paths that you can go with CityEngine and the different kind of processes also required for the production of Independence Day Resurgence?
Yeah, no, of course, that is a very good question. So basically, it depends a little bit on the role that you are playing, and if you remember the step that the different design steps that I went through with the white cubes and the building shell representation and so on. So for that, absolutely no scripting is required because you are literally just pushing some sliders and pushing some streets around and actually doing literally just the creative aspect, making buildings higher or less dense and so on and so on. Now, if you want to actually implement specific workflows, then it becomes a little bit more technical, but as also mentioned, some of the rules are available for free, or there are partners that you can contact, like for example, vrbn to help you out with that. And then if you have, or if you are working, for example, in a visual effects house or in a VFX studio, basically, then you always have very technical people at hand that I guess need to be in very close proximity to the person that implements the workflow. And there are things can, of course, get technical, but that's up to the individual project also on how complex you actually want to go.
All right. Thank you very much, Matthias, for your answer. Thank you for all your questions. And if we could not answer your question, and there is a high probability here, then we will come back to you directly via email or phone. And now let me conclude the webinar with the next steps. So if you come to SIGGRAPH, please stop by and say hi. Then you can access all the content from today's webinar with the link bit.ly/VES webinar_1607. I just posted also in the chat, so you can access it also there. Thanks for that input, Devin, as well. and just give me some time to process the video. We will also add it on our YouTube channel, and I also try to upload it into that box folder. And then finally, I would like to thank one more time Matt for your amazing presentation. Thank you so much. Then the Visual Effects Society, Scanline, and 20th Century Fox for all their amazing support to make this happen. Thank you so much. So we are looking forward to see you all at SIGGRAPH in Anaheim next week. Like I said, booth 727. You can see our CityEngine visual effects stuff online on esri.com/visual effects. And now I wish you a great Friday and a great weekend. Goodbye and auf Wiedersehen.